Hello everyone, my name is Aniruddha Jasu. I am the Technical Marketing Engineer from HP Aruba Networking. Welcome to today's session on AOS-CX 10.14 IPFIX enhancements. The agenda, as you see on the screen, is overview, use cases. We'll talk about the feature details, configuration, troubleshooting, and end the session with a demo. Let's quickly get into the overview section. Before that, we would want to understand the acronyms which are being used on this session. I'm pretty sure you all are aware of this. This is for an info to give a background. We are going to talk about IPFIX, which is IP Flow Information Export. It's an IETF standard protocol for flow information aggregation and export, also known as NetFlow version 10. NTA is SolarWinds NetFlow Traffic Analyzer. TI is Traffic Insight. AOS-CX Embedded Flow Analytics. DPI is Deep Packet Inspection. ARC Application Recognition and Control. ABP is Application Based Policy. Journey so far on the telemetry features, the IPFIX, ARC, ABP, Application Based Policies, and TI. We started this back in 10.11. There was a pretty detailed session on port-based IPFIX involving CX 6300, 6400, 8360s, app visibility, and traffic insights. The link you would see on the screen. We moved into AOS-CX 10.12, which contained ABP app-based permit deny action. In the same release, we had IPFIX enabled for CX 8100. Then we moved into AOS-CX 10.13 release update, which contained phase 2 of ABP. It contained app-based policy actions such as DSCP and local priority, remarking, and mirroring. We had pretty detailed, efficient CX IP Flow Manager session. We introduced IPFIX update for CX10K in the session. The links as you see on the screen, which can be referred later. Today, we would be talking about AOS-CX 10.14, which contains two very important features. It's role-based IPFIX supporting our CX 6200, 6300, and 6400s. We would also get into port-based IPFIX, which is enabled for our data center switch CX8325. These are new features coming in 10.14, and let's dive into the details of the same to understand better. Overview section of role-based IPFIX. Let's first talk about that, right? I have divided the screen between role-based IPFIX and the existing port-based IPFIX on these platforms, CX 6200, 6300, and 6400s. Now, the IPFIX is an embedded network flow analysis tool, right, that compiles characteristics and measured properties of flows and send flows info reports to internal or external flow collectors. With an existing way of doing port-based IPFIX, as you see on the right side of the screen, monitoring is configured on a port, right? As the name suggests, port-based IPFIX. So we are enabling monitoring on the port directly. So this is to be done who wants to monitor traffic from clients, which must pre-configure IPFIX monitor before onboarding the client, right? It has to be there. Now, if a client moves from one port to another, right, the monitor part the configuration of the IPFIX monitoring must be reconfigured accordingly to that next port or the new port. So this is very common where the clients can move around. Now, to reduce these complexities, role-based IPFIX is introduced, right, which is on the left side of the screen on the where I'm highlighting the laser. And this allows you to configure an IPFIX monitor on a port access role, right? It would be a part of the port access role configuration. So this way, the client can move around and we don't need to have a predefined configuration on the physical port of that switch, right? So once again, port-based IPFIX. Now, how do we do that? The main difference you'll have to understand is we use TCAM for port-based IPFIX, which was introduced in 10.11, as we saw in journey so far. And in 10.14 onwards, we are also, meaning both are still existing, right? We are also introducing role-based IPFIX, which would be IP flow table based, right? Now, the, unlike role-based IPFIX, port-based IPFIX can actually be monitor flows of the uplink interfaces, right? On the port-based, we can do that, but on the role-based, uplink monitoring is not possible. We can still use both on the switch, right? So when we do role-based on an access port, right here, where authentication is to be enabled, for monitoring the uplink ports, we can use port-based, right? We'll talk about that a little more detail. But in the role-based, as I said, IP flow table is leveraged to get the flow statistics. Now with this role-based IPFIX, when a user plugs a device, as you see, into a specific port, their user role is applied to the port. Whenever the user plugs that device into a different port again, the role is applied to that specific port, right? The role already has the configuration, so it just have to can move around basically. So this gives mobility and accessibility to the user and provides permissions specific to the user's role when the user's device move across interfaces. Role-based IPFIX enables colorless port behavior, which is very important, right? And this this has been new in 10.14, and we are leveraging the existing infrastructure of port access role. Now, if the question arises, since both are supported, if a port has both role-based IPFIX and port-based IPFIX, the port-based IPFIX implementation takes the priority. We'll talk about that how. So this is how the usual overview of both port-based and role-based on these three platforms today. Let's also get into the overview of 8325, which is different, and it is only port-based IPFIX. There is no role-based IPFIX on 8325s because, as you saw, role-based gets applied to the authenticated clients at the access ports, right? It gets authenticated and then we apply role. Now in port-based IPFIX of 8325, what's new? How do we do things, right? It's mostly revolving around two tables, that is TCAM and exact match table, which is a hash table again. Now we'll talk about that more, but in this overview section, what we need to understand is that on 8325s we support I'm so sorry, port-based IPFIX, and it leverages the tables which I have shown on the screen. The visibility, which is the network flow, helps gain deep insight of network performance and can identify potential issues. That's general IPFIX behavior, right? That's why we use them. With the flows, Another use case would be strategizing optimization of network traffic flows, which in turn can be utilized for latency reduction, balancing load across network paths, which can in turn help utilize available resources efficiently, right? For 8325 platform, IPFIX is only supported on leaf profile. Profile of the switcher should be on leaf. A maximum of one flow monitor can be created and one flow exporter that can be applied to a single flow monitor. Both the physical and lag interfaces can be monitored in port-based IPFIX 8325. Exporter support on default VRF only, right? You will see that in our demo as well. It has been tested on Elastic Flow, which is on Elastic ELK stack. There is a support of source interface for IPFIX packets. In VXLAN environment, IPFIX monitoring doesn't give visibility to inner payload when monitoring on interface that receives tunnel encapsulated traffic on leaf. What does it mean? If we monitor the port where we are ingressing overlaid traffic, that is before encapsulation, that can be exported. It's just the use case of monitoring port that is connected to spine, which receives encapsulated traffic, will have the above mentioned behavior. That's in the VXLAN environment. And this is important to understand. TCAM on 8325s acts as detecting the flows, and exact match table is used for storing the flows. That's why we use two tables. Unlike the port-based IPFIX on our campus environment, which is 6300, for example, where TCAM is used for both detection and storage, right? Here in 8325, we are using TCAM for detecting the flows and exact match table to store the flows. Since TCAM is a high demand resource which is shared across multiple protocols, including the security protocols, IPFIX flows are detected but are stored in a different table, that is the EM table. Now, this EM table is used by other features like L2, L3, and multicast, etc., to achieve their feature scale. Right? That's the difference between these two. And that ends our overview section of CX8325. I hope you understand the differences between three IPFIX way of implementing. One is port-based IPFIX on our 63, 64, and 6200s. The other one is role-based IPFIX, which has been introduced in 10.14 for 62, 63, and 6400s. And there is one port-based IPFIX on 8325s. Now, platform support, as you see so far, and this particular table talks about what's new on 10.14.001, right? We have role-based IPFIX, which is supported on 6200, 6300, and 6400. This is completely new in this particular release. We had port-based IPFIX on 6300, 6400, 8100, even 8360s and 10,000, CX 10,000. In the past, what's new is port-based IPFIX has been introduced newly on 6200 and CX 8325 in 10.14. Now, we all know what Aruba CX Edge Insights is. This particular table is to give you insight of what we support, what all is available, combining ARC or application recognition, basically, not the control. Application recognition, IPFIX, and traffic insight gives us the edge insight feature set of CX. Now, you see on the screen we support 6300 and 6400 for application recognition. For IPFIX ingress, it's supported on all these platforms, as you see on the screen. Traffic insights have some information which you should know. and I have marked that very clearly at the bottom of the screen. TI on 6200 is available from 10.14.001 onwards and supports app and raw flow monitor types. Now here, catch is app ID will be unknown as application recognition is not yet supported on 6200, right? So these are important. TI on CX 8360 supports only DNS average latency monitor, which requires client insights to be enabled. I think this is well known. It's been there. TI on CX 10,000 supports top-end and flow monitor types from 10.14.001, which is new, right? Onwards, and workload flow monitor type was supported from 10.13.0.0.05 onwards on CX10K. And TI on CX8325 is available from 10.14.100 software, right? And onwards and includes top N and flow monitor types. These are the two which are present on 8325s. I hope this particular slide gives clear understanding of where we are at with respect to release support as of today. All right. Now let's get into the IPFIX role-based new flow detection mechanism, right? How it is happening, what do we do, right? To understand that. You understand the topology here where I have enabled role-based IPFIX on these interfaces, and it's it's role-based. So we have authenticated clients here, and we have TCAM-based uplinks here on the uplink interfaces. I have both IPFIX, IP flow table, and IPFIX TCAM for the uplinks table identified here. So the first step, client sends packet to switch port, right? Authentication is triggered. If authorized, assigned with a role, this is when IPFIX monitor gets applied if present in that role, right? Then the PC1 initiates traffic unicast and not multicast. Remember that to an application server, as you see on the screen. After DNS resolution, packet is forwarded to destination by ASIC, no software forwarding, right? Now, IPFM will copy the flows to the LC CPU and program that IP flow table in the hardware. First ingress packet is copied to line card CPU for flow management processing due to flow miss in the ASIC IP flow table and flow monitor enabled on the receiving port, client facing port. Here, a new 5-tuple flow entry in the IP flow table is created after maximum 15 seconds. That is, the 5 tuples are source IP, the destination IP, which is this table here. You see source port, destination port, and the protocol. ASIC IP flow table, which is also hardware based, as you know, will count the flows, bytes, and packets without any CPU processing. Now, server response packet is forwarded to the client by ASIC. First return packet is copied to line card or CPU for flow management processing due to flow miss in the ASIC TCAM and flow monitor enabled on the receiving port, which is uplink at this time. As we already discussed or understood, role-based cannot be enabled on the uplink, so TCAM is used since uplinks are not port access interfaces, and role-based IPFIX cannot be enabled on the uplinks. Reverse flow return uplink, that is, a new 5-tuple flow entry in the IPFIX TCAM is now created after max 15 milliseconds. Those 5-tuple we already know. It's all there in the TCAM now. Subsequent packet, which is this, are counted number of packets and number of bytes by ASIC TCAM without any CPU processing. That is the reverse. At the end, all this uh, flow detection, flow update, etc. Flow state is now monitored regularly, and when flow expires, flow IPFIX information are exported to the collector here. Hope this was useful. New flow detection process. Now, let's talk about the flow termination and removal process of the same flows which we just discussed. Now, this is specific flow removal from IPFIX IP flow table because this is role based. So you see, TCP FIN or TCP RST is detected in 1, 2, and 3 steps. Flow entry age out due to inactive flow cache timeout, 30 seconds by default. Inactive flow state, which is packet counter, does not increase, right? Flow entry age out due to active flow cache timeout, which is 1800 seconds by default. Active flow state would be packet counter increases. Now, if one of these conditions is met, flow information are exported, which is here. Note, when a flow entry aged out, subsequent packets in the flow will be considered a new flow entry, right? All flows from a given port removed from IPFIX cache, not from IP flow table. Reasons for those behavior as you see on the screen below. Now this is IPFIX perspective and not ARC, right? The flow monitor is removed, interface is shut down, port access scenarios, client log off, flow age out. These are the reasons which may be seen, right? Now let's move on. The use cases, right? Now, for the role-based IPFIX, with support for IPFIX implementation via port access roles on these platforms, now you see there's an IP flow table which we discussed in detail, right? What are the use cases? Now we can use ClearPass Policy Manager plus downloadable user role to achieve role-based IPFIX, right? Have ClearPass policy role to have an IPFIX monitoring command in that and send out to the authenticated client. We can implement this via CPPM plus local user role as well. We can use a radius plus local user role. We can have a device profile plus local user role. One of these, right? It can be used in a single or multi-fabric EVPN VXLAN environment and non-VXLAN environment. Now, in L3 VNI environment, right, we need to understand that we can use port-based IPFIX uh, today, not role-based IPFIX. Okay, we'll talk about that. So that's why L3 VNI is mutually exclusive with role-based IPFIX. For ingress IPFIX monitoring done after VXLAN decapsulation, IPFIX statistics are related to overlay, right? Let's get into the use cases of port-based IPFIX in 8325s, right? Now, in the campus deployment, you would see them in these ways that we can leverage it, right? On the left extreme side, you'll see we are using port-based IPFIX between aggregation uplinks and downlinks, right? This is the aggregation layer, and we are using, and all of them, core and aggregation, both are, let's say, CX8325 in this use case discussion. And in the aggregation layer, we have this 8325 for both uplinks and downlinks, right? This way, we are making the configuration simple as flow monitoring is on uplinks and downlinks. The EM table and TCAM size of aggregation switch now should handle all the flows crossing the access network, right? All of them are getting through this aggregation layer, and since we are monitoring on the downlinks, all of them are getting monitored at this level. So IPFIX configured is only done on the aggregation layer here in this scenario. So all the access, no matter how many access layer switches are there, all of their traffic is getting seen here. Now, if we have to configure between aggregation and core, now mind it that why have I used a slash here in these two scenarios? Because core is involved, and in the core, if you want to use IPFIX monitoring, we have to understand that it has to be in the leaf profile, ideally. As long as there is leaf profile, you can use it. If not, we cannot have this use case, right? So assuming that you are using leaf profile on the core, then the IPFIX is between only the ag and the core. Now, what will happen here? Although the configuration is simple, monitoring is done at a very simple level. and you are getting all the aggregation layer traffic seen on the core, right? In this implementation, the drawback would be that you won't be able to monitor east-west traffic within the aggregation, right? Because access layer type of information is not there. Similarly, on the right extreme use case, you will see that you are only configuring it on the core as long as the profile is leaf. So when you're configuring it on the core, that means the downlink of the core and the uplink of the core. So that means you won't be finding the east-west traffic. You won't be having the aggregation layer switches traffic. Just whatever is hitting the core is what you would see in the collector, right? So although the configuration is simple, you won't be able to get the east-west traffic scenarios in this. Getting further into the data center side of the house, when you are using port-based IPFIX on the 8325s, in this scenario, you can have on the switch the interfaces facing the workloads as well as the uplink, right? As you see, especially when you have to understand that if you're using um, monitoring on the uplink connecting to the firewall. Imagine you are having entire network monitored, and you will have a cumulative outputs in the collector to understand which workload is having what type of issue or what type of traffic, how much is it using, what type, for example, DNS or other HTTPS traffic or SQL, etc. Right? So you will get to understand everything in single pane, right? So a maximum of one flow monitor can be created and one flow exporter that can be applied to a single flow monitor. Suppose only IPv4 unicast flows. Now we can monitor both physical and lag. Exporter support on default VRF only is tested on Elastic Flow on Elastic, right? Um, as of today, not on SolarWinds NTA due to a particular issue. So you would see that we are supporting Elastic Flow as of this release. Can be used in single or multi-fabric EVP and VXLAN. Now, IPFIX monitoring done here does not give visibility to inner payload when monitoring on interface that receives tunnel encapsulated traffic on leaf. Now, if we monitor the port where we ingress overlay traffic before encapsulation, that can be exported, right? It's just the use case of monitoring port that is connected to spine, which receives encapsulated traffic, will have the behavior as mentioned above. Hope this particular use case is clear. Let's dive into the details of this particular release features. Now, for the role-based IPFIX, which is nothing but our 63, 62, 6400s, we support 16 exporters, 16 monitors, and 16 records, supporting a maximum of 16 flow monitor with a limit of 2 exporters that can be applied to a single flow monitor. These are the timers which can be configurable, supports both IPv4, IPv6, and ingress only support. As you know, CX supports only ingress IPFIX on all the platform as of today. Support for unicast traffic flows only, no multicast on role-based IPFIX. Support for ICMP. We must manually enable ICMPs, which is also introduced in 10.14. I have the command snippet here. I'll show you that. Support on L2 port only, where the port access roles gets assigned, right? Because on the L3 ports or on the uplinks, we don't have roles guessing at time. It's not getting authenticated, basically. Both collect timestamp absolute first and timestamp absolute last are supported. Timestamp absolute first, which is nothing but collect the absolute timestamp of the first packet observed. Similarly, the last packet observed. Supported IPFIX collectors such as Traffic Insight, which is the internal collector, as you know, SolarWinds NTA, and ELK Elastic Flow. No sampler, one out of one counted packet out of one data plane packet. Now this is the IPFIX behavior. Export data template. Now, as you see, what are those end flow end reasons? There can be idle timeout, active timeout, end of flow detected, force end, etc. Export types, what are those types? We have data template, options template, and data. I think these are all pretty much known and covered in previous TOIs as well. So we support these three types. And IP datagram, IPFIX datagram is on so UDP port for 9995 elastic flow for 2055 solar winds. Exporter could be from a chosen VRF, right? One report per flow. That is important. I'm going to show them in detail in our PCAPs, right? So this was the command I was talking about, which is newly introduced in 10.14 to track ICMP in the flow tracking command context. Further getting into the same role-based IPFIX, there are 6 mandatory match fields, of which the IP match field must be on the same type, separate for IPv4, separate for IPv6. Supported sets are so and so, as you see on the screen, and I think it's well known. A flow record is invalid if it does not contain one of the supported sets of match fields, right? It has to be all of them. You have to configure all to have it. Further, these were the mutually exclusive features which I talked about in the initial slides now and also in the architecture. There are some mutually exclusive features that will disable role-based IPFIX when they are enabled. Those are this UBT, MAC lockout, extended MAC, source port filter, IP lockdown, L3 VNI, and VSF stack. If you have VSF stack, you cannot have role-based IPFIX as of today. Also, the following behaviors are observed in a deployment with role-based IPFIX. Very important. I think I have covered it. Just going to read through. If a user applies the IPFIX monitor configuration on the port, it uses the existing TCAM infrastructure, right? Because this is port-based IPFIX. If a port and has both role-based IPFIX and port-based IPFIX, the port-based IPFIX implementation takes the priority. If IPFIX monitor configuration on a port moves from role-based to TCAM-based or vice versa, excuse me, existing IPFIX flows learned on that port are deleted. When the user role has an IPFIX configuration and fails to apply it, port access locks it, but it does not prevent the client from getting authorized. Of course, right? Because the authentication portion comes first. If port access is in the client mode, right? You remember there are two modes, device and client mode. And if there is more than one client with a conflicting IPFIX monitor configuration, traffic from all the clients will be exported through the IPFIX monitor configured for the first client. So it's better to have separate authentication, right? Then you will have can send only one by one, and I'm showing that in my demo also. Role-based IPFIX and TCAM port-based IPFIX implementation can coexist on a switch. I think it's pretty clear by now. Flows from unauthorized clients are not monitored by role-based IPFIX. These can be monitored by port-based IPFIX. As long as, so the thing is, as long as whatever type of role it is, if you have IPFIX monitoring command in that role and it's getting applied to an authorized client, then you can have a flow monitoring done on that interface. Now, whichever way you want to send the role, it's depending upon the implementation. Excuse me. Let's get into the port-based IPFIX of CX 8325, right? Just to be clear that we support only one exporter, one monitor, and one record as of now. 8325 active flows are exported every 60 seconds. I explained this, and we cannot manually change it. We can control, however, inactive flows, inactive timeout, and can change the value. Default is 30 seconds. Active timeouts, it is 1800 seconds. Collect timestamp absolute first is supported on 8325, but not timestamp absolute last, unlike the 6300s in the previous slide, right? Collect counter bytes and collect counter package is required for collectors. Of course, all supported match fields are mandatorily needs to be configured for IPFIX to work. Yes, IP 8325 exporting is hardware ASIC based. Now, remember this 8325 supports export only via default VRF as of today, meaning the exporter should be reachable via default VRF. The L3 routed path towards the exporter will have a next hop or the exporter itself if locally connected, right? That's how it is going to work. The next hop must be reachable, having an app entry before 83.25 will start collecting the IPFIX stats. Okay. Now this can be seen with these commands as you see on the screen. Observation points, what all can we observe, monitor? We can use L2 port, L3 routed port, L2 lag, L3 lags to monitor all of them. We can also even do split L2 port and ROP port, routed ports. For example, if user has used split cable, then physical port can be split, and that physical port could be an L2 port or an L3 port, and we can monitor them. Sub interface ROP and lag, which is but only the parent interface. What does it mean? It means we can apply monitor to parent interface only in user configuration. It will implicitly monitor flows on all sub interfaces of that parent port. In other words, if we want to apply monitor to only one sub interface of a parent port, then it's not supported. We always get to monitor all. Okay. MC lags we can support, but no support on SVI. Supported on ELK Elasticflow, no SolarWinds NTA support as of this release. IPFIX is only supported on leaf profile. We know that, we already discussed it, and the reasons for it. Only IPv4 unicast flows are supported. Support of source interface configuration to export IPFIX packets. That's on from this release onwards. We can manually define which source interface we want to choose. The use case of this could be have a better customization or control over the exported flows and how they are provided, since the user can now configure the source in a way that is more beneficial for their setup compared to the default generic implementations. For example, source interface loopback is easier for operator to track equipment source well on loopback IP. So we can use that. Okay, let's move on. On 8325, IPFIX does not monitor unresolved IP unicast traffic or ICMP traffic, right? So any traffic still being ARP or neighbor resolved that is received on interface with IPFIX monitoring will not be learned, and flow reports will not generated for that traffic. Once the traffic has been resolved, IPFIX will start reporting those flows. Any ICMP traffic currently being received on interface where IPFIX monitoring has been applied will not be learned, and flow reports will not be generated. So remember that this is one of the things. These are few arguments which may happen when you're configuring IPFIX on 8325s, which are pretty straightforward. When you're configuring an exporter which does not even exist, we get a flow exporter does not exist output. Similarly for the record and for the monitor, while configuring and calling out those flow monitoring names. Similarly, if you are trying to define more than one exporter, because we only support one, it says unable to create the exporter, maximum allowed is one. You have reached the max. Similarly for record and monitor, I said 111 is what we support today. Similarly, flow monitor cannot be applied while interface is part of a lag, right? It's already part of a lag, so apply it on the lag. Let's dive into the configuration. For the role-based IPFIX configuration involving CPPM plus DUR, for example, we are using ClearPass for authentication and role apply downloadable user role from ClearPass. These are the configuration which will be mandated. So which will be required. As you see, flow exporter, we are defining IPFIX export as flow exporter. This is the naming convention I've used. We define destination. This is your excuse me, the IPFIX collector, which is what you have. That is the IP address, and I'm using a default VRF. For example, it's reachable through that, and the transport UDP interface or the port number of UDP is 2055. That's the collector based on whatever collector you have, and I have given you certain well-known UDP port numbers in the previous slides on what all type of, if it is SolarWinds, what would be the collector UDP, if it is Elastic Flow, etc. Flow record. So you have to define like this. Flow exporter is defined. Flow record. If you're using IPv4, you use a separate flow record which contains match and collect fields such as this, the 5 tuples here, the port, address, protocol, version, And then the collect fields, application name if you're using, application recognition if you're planning, counter bytes, counter packets, forwarding status, application HTTPS, timestamp, etc. If you're using V6, use a separate flow record for that and define the match and collect field for the same. Then finally, to monitor, you use define which monitoring you will be using and what type of exporter. If you're using exporter IPFIX, this one, you define, you call that out, and which record are you going to monitor. So you call that out here. I've used separate IPv4 and IPv6. No IP source lockdown resource extended, right? We are mutually exclusive. So bold one to understand that this is an important configuration for role-based IPFIX. In the role-based, we have new thing which is flow statistics enable. This command makes sure that role-based IPFIX works. So ensure that this is just flow tracking enable does not help. And it is CPPM plus DUR. So I'm using interface 111 port access onboarding method, AAA authentication port access .1x authenticator enable. This is well known, and I'm using both. And I'm using the source interface 1124, which is where my collector is collected. So I'm leveraging that, for example. So in the CPPM configuration, it's pretty straightforward. In that role called IPFIX DUR, for example, in my enforcement profile, I define um, in the role, whatever role you are using. For example, in radius Aruba type, name, so CPPM role, I'm using IP flow monitor and this IP flow IPFIX monitor role in that, and I'm sending that to the switch. So for the authenticated client through .1x or MAC or whichever way, that this particular role gets assigned, which contains the IP flow monitoring command in it and gets applied to that client wherever it goes. Okay. Similarly, to understand the validation, once I've done that configuration on the switch side, we can validate that by saying show port access client detail, and you see IPFIX monitor is what role has been assigned, right? Name is IPFIX DUR, which if I go back to the screen, you'll see IPFIX DUR, right? And the flow monitoring is IPFIX monitor. So if I go back, if I come back to the switch, IPFIX DUR is my role and it's getting applied, and the IP flow monitor is IPFIX monitor naming convention, which VLAN 168, for example. So port access client, if I do, you'll see the user role and the VLAN, etc. If I do show flow monitor IPFIX monitor, that particular monitor, it says it's been accepted, and it's inactive timeout is 30, active is 1 and 1800. Which flow record, so and so flow record, which flow exporter, so and so flow exporter. So that configuration is already on the switch. It's going to leverage that. Okay, so let's get into another use configuration use case. I'm using LUR plus device profile, for example. So I'm using no clear path this time, and all of these configuration remains the same. For example, exporter. So I look at this. I'm using two exporter, right? One is for Elastiflow, another is for SolarWinds. So I can use multiple. There are 16 which I can leverage, right? I have explained that in the previous slides how it is restricted and how many we can configure. And I'm using this record for IPv4 traffic. Same commands, flow tracking, flow statistics enable to get the role based working. Now, since it is device profiling, I'm doing all those MAC grouping port access on the switch itself. There is no CPPM here. See on the diagram as well. Now, so I'm using MAC group, name this, and then I'm saying use OUI. So all my clients have a MAC OUI of 0 to 1 AC5. So I'm calling them out. So once I do that, I am also creating a port access rule, and that is where I'm defining the command IP flow monitor and this monitor. This name, right? Instead of having a role from CPPM, I'm using local user role, which is this, and then in port access device profiling, I'm enabling that and associating the particular port access role and associating the MAC group. At the interface where the client is, I'm authenticating and I'm saying port access device profile mode block until profile applied. So it gets applied with this particular port access role. So either way, whichever way you are defining the role, you ensure that IP flow monitor command is there. Okay. Uh, to validate, right? I'm using same LUR plus device profiling. If whatever configuration I've done in the previous slide to validate that show port client access, show port access clients. These 021AC5 was the MAC OUI, and I'm seeing all of these are getting the role IPFIX, which I defined in the configuration. So I have multiple clients connecting to the same interface. So all of them are getting authenticated because I used OUI, right, to authenticate. And further getting into that particular client detail, you will see that it got applied with the profile, device profile. This is what I had defined in the previous slide. And the role and the MAC group, there's no failure reason because it was successful. It's the same for other client as well. Okay, so to understand the PCAP, for example, I have monitored a particular role-based client, and how does the role-based client IPFIX PCAP looks like? So if you see, I'm this is how the data template is looking like. The template would contain the template ID, and then it has multiple fields, those tuples, IP destination address, source VLAN protocol, protocol version, flow and reason, right? And then all those information which is there in the one particular um, data template. So this is the template, data template PCAP, which you're seeing. Let me expand all of them. Okay, this is how it looks. Now, let me try and go to the data itself. If data template 257, that is the template which is being used, and where is the data? Data is here. In that data, the template frame you see is 39. 39 is on the top. The flow one now contains the data of that particular data template, right? Template does talk about what all should contain, and data contains the information of that particular flow, like source, IP, etc. There is another called as option template, which contains application ID, application names. If you're using application recognition also enabled, option template will contain those fields, and option data would contain the actual application name. So here it is DNS and category name, etc. So this is how an IPFIX PCAP looks like. So you see the flow, source IP. For every source, different tuples, there's a different flow packet. Template ID would remain the same. There is a different template, the different packet would be tracked in that way. Okay, let's get into further data template, which I just showed you. The data template, you see, it looks like this, right? The data template shows that what all should the field be used to define in the data, right? So data template with relevant fields for your reference, and I've expanded that in my previous slide for just for your understanding. Now, in that data, what data with flow set outputs, right? Data template we just saw. Now we are seeing the data itself, which follows the data template and gives these information. All those template contain these headings, and now we have the data inside. Source address is .44, destination is .37 of that particular flow. Flow and reason was idle timeout, etc. So if there is a change in the tuple, there will be a different data packet. So what I'm trying to show here is separate flow data packets sent for each communication, right? So data template could be same. Now this data packet 40, it has source IP, source address as .44, destination as 37, source port as 53856, destination port is different. Now port packet number 42 of the same template, which is 39, here also is 39. Same data template, packet 42 having a different flow, right? Because there is a source port number and destination port number is different. Why I'm showing this? Because you have to understand for each change in the flow data, there is a different flow packet, which is not the case in 8325. We'll see. We'll show you that. Option template I highlighted in the previous slides. Option template and its data. It looks like this. If this is option template contains the application ID, application name, etc. And relevant data of that would be here. If application recognition is enabled, it recognizes via option templates and data flows. Now let's get into port-based IPFIX configuration of 8325. You see the flow exporter I have defined as elastic flow, its destination, the transport UDP port number. Now here there are less fields when comparable, right? Flow record for IPv4 is match, destination, source, protocol, destination port, source port. That's it. And then the collect counter bytes, packets, and timestamp absolute first. Remember, there is no absolute last as discussed earlier, and there are many other collect fields which are not available, but these are the ones which are available as of this release. And then flow monitor, under flow monitor we choose which exporter we have to use and which record, right? Since it is just one and one we support, we am using that. On the interface, this is port based, so I'm getting into the interface and defining IP flow monitor and calling that monitoring description in the ingress direction. So trying to highlight that this is the command to have port-based IPFIX configuration configured on interface of the 8325. I'm also using the source interface IPFIX feature to leverage where my exporter is. Let's say my exporter connects to interface 1 to 124 here. Since it has only supported under default VRF, I've also highlighted that here for your clarity. So I'm leveraging that feature to define to use 1124 as my IPFIX collector source interface. Pretty straightforward configuration, just this and the flow information. Under port-based IPFIX inside of a PCAP, it looks like this. I'm using this data, right? You see in the data, I have many flows. When compared to, for example, 6300, each packet had a different flow. So good thing about this is here is 8325. All the flows every 60 seconds. Remember, active flows are sent. So all these are active flows which are being sent and in one packet. Okay. So you see if you see the source port is different here in each flow, but the packet which is being sent is single. So it sends out all these in one shot. There's no separate to track. Okay, also different. Okay, so data template of 8325 looks like this, and it's relevant information as you see when compared to others. It has 1 to 8 IP, destination address, source address, protocol, L4 destination port, source port, bytes total, packets total, and the flow start. Similarly, for data template, the relevant data is this, and I have showed that in the previous slides, but this is in detail showing each packet contains so and so flows of different tuples. Multiple flows are sent in single packet. That's about the configuration and the insights of the IPFIX. Let's get into the troubleshooting, understanding that, let's say if it is a role-based IPFIX and there are multiple clients, Mac, you can see I've used here Mac OUI. So all my Mac, multiple Macs are there on a single interface, and it is working well. And to check that out, you can use these commands. IPFIX role gets assigned to Mac address set in the configuration. Have to understand that on the MAC address table, it should be there. It says whatever type of authentication port access security on that interface, and then the port access client. If it is a single client MAC, you can check, define in the profiling the exact MAC address of that particular client, and then you will see that on the show port client MAC, that is assigning the user role to that particular MAC only. The rest of the Macs, it is not assigning any user role, because in the device profiling or whatever authentication method, that is the only client gets authenticated. That's why that's the only client which gets the role. Further getting into the event logs, for example, the event logs to provide indication on client limit exceeded. This usually happens if you have multiple clients on a single interface, but the client limit is given as one. Even if you have 10 clients authenticated, it won't work out because it says client limit exceeded. I think it's a well-known factor for an unauthenticated client. A separate class for IPFIX is available in COP policy and shows us rates in PPS, which is 2500. As you see on the screen here, show COP policy statistics class IPFIX. Warning messages are sent out for an unsuccessful role-based for an unsuccessful application if there is an VSF. For example, you have VSF, you're trying to define this, you'll get this error. If you're doing an L3 VNI, right, you'll see this warning message. This configuration will disable flow tracking statistics collection. And also, if you're trying to define more than 16 flow exporters, you will get no more than 16 flow exporters can be configured. Another flow exporter must be removed first. Further to understand, maybe just as a bonus tip, with the repetitive monitoring statistics, we can track the flows getting added and other statistics. So if you want to manually see on the switch itself whether switch is sending out the flows and it is getting monitored, you can use show flow monitor statistics multiple times, and you see the flows getting added gets increased, flows getting terminated get increased, which are in inactive timeouts, which are how many end of flows are getting detected, is all getting tracked here on this command. Troubleshooting port-based IPFIX on 8325, mostly the same commands, right? Won't get into this more. Just to highlight that if I try to configure more than one flow exporter, you get this error. Try to configure more than one flow monitor, one record, you get these errors. Show flow exporter statistics command remains the same, and you can use that here. Commands remains the same. Similarly, show flow monitor output looks like this. Show flow record output looks like this. And here also the COP policy statistics for IPFIX on 8325 is 2500 rates packets per second. I have a detailed slide um, on that. Let's see. You can do a diag dump IPFIX basic to get all the relevant details about IPFIX on particular switch. So here you see there is an error which says IPFIX management PD not supported in the current profile. So if you see show profile current, it says L3 core. It needs to be leaf, right? We can also use show tech IPFIX to get all the relevant outputs of the IPFIX on the switch. All right, let's get into a demo. Let me try to highlight the topology. Now, you see I'm using the same topology for both, explaining both role-based IPFIX on 6300 and port-based IPFIX on 8325 here. One thing you have to understand is that I am having authenticated client here on the 6300, right? And there are around 9 clients. You will see them in the IP range 33 to 42. Similarly, on 8325, there are clients 22 to 31, with the server being 11 and 44. Okay. 6300, I'm sending it to SolarWinds NTA as well as Elasticflow basically, but for 8325, it's only Elasticflow. So these are the IP naming conventions. So I'm going to communicate between the server and the clients basically, and see how the flows on interface 111. You'll see 9 to 10 clients here, 9 to 10 clients on 6300 also, all of them. And I will have a separate demo to show you on 6300. If I have only one client authenticated, then remaining will not be seen in the collector, right? So the configuration of role-based would be this, which I've already explained in the configuration slides. Exactly the same, okay? And I'm going to use right now multiple clients. So around 9 to 10 clients will be seen with the Mac OUI of 021AC5. Okay, let me get into SolarWinds NTA first with 6300 role-based IPFix. So here you see 6300 is being monitored, and you'll see all those uh, clients which got authenticated, right? And shows the output in the top 25 protocols, top 25 endpoints, and all of these clients, as you see here, that is what I showed you on my slide as well, all are getting recognized. And you'll see these are the applications which are being leveraged, because I have application recognition enabled as well. Top 100 conversations between those clients, it will show in pretty detail on that particular day of and time. So these are the services, and if you see N bar, this is network-based application, it will show you all the applications which are running right now as we speak and getting monitored. With this, you'll also understand which application is leveraging more bytes, more packets. So you'll see DNS is most utilized, so you can click on that and see which clients are leveraging those packets. So you can also filter them out, right? So if I want to search by, let's say, HTTP clients who are using HTTP traffic the most, I can use HTTP protocol, search with that. In the last 1 hour time period, as you see, let's wait it out. And we can filter out, okay, here it is, and I want to see on which switch. So this one, 6300. I'm seeing the interface right now. I have only one interface connected, so I'll click on that. So it is that easy to understand which interface of which switch is leveraging or using most HTTP traffic, and you can filter out based on HTTP, and you can see which application is being the most utilized HTTP here, which are the clients of that switch sending out. Since I'm using one interface and I have 9 to 10 clients there, so it's showing all those clients here on the top right. Um, since this is receivers, it will also show you which receiver, that is a server name, at what time of the day, how much packets or bytes have been sent by which client, and why. We can, with this, we can analyze, right, the network, analyze and control the network if there is an unnecessarily bandwidth utilization by a client, by a service, by an application. This particular IPFIX configuration implementation can be leveraged and figure out uh, further dissection of the network. We can also filter out based on the time of the day of the month, and and then get the information to see what happened in the past, right? So it's pretty detailed in that way. Let's get into another collector. Same configuration. I have used two collectors because 6300 supports more than one. So same traffic, same clients as you see here, right? But a different collector called Elastic Flow, which is installed on Elastic, and it looks like this. So this is that host 240.4, which is my 6300, and these are, let's say, these are the clients and the servers, right? It looks different here, but in the same page in the overview section, you will see what type of services are being used, like HTTP, DNS, everything, right? If you want to see top N, like how we had top 100 conversations, traffic, and SolarWinds, we have top N talkers here, and we can filter out based on the time here in the last 15 minutes, who are the talkers, top end talkers here, whether it is HTTP traffic, DNS traffic, and between whom, which are those clients. On the left screen, you'll see clients and servers, right? Which are the top services? You'll see DNS is the top services, which has more flow records. And why is that? Is there a questionable number, etc., which can, based on the client network, can be defined. We can also have conversation between client and server, track them here, right? Which are those core services on their network which is running and utilizing the most. So you see, this is the DNS. Similarly, radius traffic is at peak at such a time of the day, and which date was that? Why did we have so many auth requests, if at all? Right now, it's all normal because I have a controlled environment, but we can leverage that. This is all is happening based on the IPFIX data which we just sent out through the configuration I showed you, right? So the client and servers are defined in this way, and we can track, we can click on them and we can track them. Exporters are nothing but which switch is sending out the IP flow. To understand that, you have multiple hundreds of switches, we can filter them out here one by one, and see how many records are being sent by which switch of the network. Right now there's only one, so I will see only one switch here. To also talk about which IP version. IPv4 is what I'm using, not IPv6. I've removed that config, but you can use that. And I'm using VLAN 168, so that is what, in this it is VLAN 800, and VLAN 1 is what I'm being monitoring. So it shows VLAN as 1. Approximately 9 to 10 clients. There's only one or two servers, but it is talking to other servers which are not being monitored, but are there, right? So it's monitoring everything. This particular thing will show you what type of flow records we have in that flow, each flow, what are those information which we get. All those tuple information are also seen here. Okay, so this is about Elastic Flow demo with all those 9 to 10 clients. So if I use the same, for example, same configuration, I have used a Mac OUI, right? If I use a single MAC address, which I showed you in my troubleshooting scenario, only one MAC address I authenticate and rest of them I do not, none of them will get the role, just one MAC address would get the role. So with that configuration, I have done that also, and with that configuration, you will see in Elasticflow or SolarWinds, there is only one client which is being authenticated and unobserved, although there are 9 clients which we just saw in the previous demo. So here also, if I use only one client, it is monitoring one client, and that's how it looks like. The collector will just show you one client information, which is very rare, which may not happen because in a network you have thousands of clients, and this particular screen would make sense if you have more clients in place, which is what I did in my previous demo just now, right? But I was trying to highlight that we can do this and we can also monitor that. That's the power of role-based IPFix. Let's get into let's get into 8325 in my next slide. And Here also, the configuration remains the same as I showed you earlier. Same elastic flow collector, record, and monitor, and we are using IP flow monitor on interface 111. Okay, so if I go back to, this is my 8325. I'm trying to monitor the clients on 8325 here on elastic flow, right? So you see the flow records are 347,129 records. So and so conversations are being used on DNS is the traffic. It shows pretty detailed on what is the client name, IP address, which switch. This is the exporter. That means which switch. This is my 8325 and their conversation ID. So let's dive into this a little more, right? So it will show you the source and destination based communication on that particular time of the day. If you expand that particular flow, it will show you all those tuple information, L4 ID, L4 name, source IP, etc. Right? What time of the day did we get this flow? What did it contain? Right? We can all troubleshoot based on that as well. Interesting thing would be to see in the traffic details of that 8325 clients. You will see which layer 4 protocols, TCP or UDP client traffic was that. Was it IPv4? And then those are the clients and their IPs being monitored here, right? Under exporter, you will see which switch was that, how many records did it send out per 60 seconds or per 5 minutes or 15. You can filter them out. That's depending upon the collector. Under flows, you will see the client source and destination communication between the clients. We can graphically filter them out and see um, how many communication did they have at that time of the day, right? Like for top end talkers here, you see the communication between them. Top services, there has been TCP and UDP. That's why you will only see them, but you will find mostly in the real environment, in the data center, all those SQL traffic or any application traffic, email exchanges, etc. All that would be seen here, and you can filter them out as I showed you earlier on maybe 6 months back at so and so time, how was the traffic and who was communicating with whom. If there is a DNS traffic a lot or any other unknown traffic which is not required in a data center, right? Uh, you want SQL based traffic to be monitored correctly. So, but there is some kind of a DNS traffic which is eating up the bandwidth. You can filter them out here, find out which workload is doing that, and we can block them basically. So that's the usage and the power of IPFIX. And now we have that on 8325 and leverage that. All right. With that, I would like to thank you everyone for being patient. It was a pretty detailed and lengthy session. So thank you very much for your time and have a great day.